welcome. I guess okay. Yep, the recording is up. All right. Welcome to the workshop on Python data preparation and also consider data cleaning and data exploration, where we will dive deeper into it. Okay. So I'm your host today. I'm Vandik. I'm a Microsoft Learn Student Ambassador beta level. And without further ado, today there are actually slides, but the slides are eventually what we will be doing in Jupyter Notebook later. So what I will need you guys to do now is you need to go to this page. Let's share this across. Okay. So go to this GitHub page. I will need you guys to download this down and open it in your text editor, which in my case, I'm using VS Code. And of course, if you are not seeing something like this on your end, I think you guys need to install certain what is that extension to make that visible. But let me know once you guys open the Jupyter Notebook, which is in .ipymb, do you actually see something like this? All right. So I give you guys a couple of times to actually have access to the content on your end. And yeah. Okay, so as usual, if you have any questions or you face any issue throughout the whole workshops, you can just unmute yourself. And of course, you can also text in the chat so I can help you accordingly. All right, cool. So I give you guys until 8:38 or 8:39 for you guys to have that set up on your end. So for anyone that missed out the instructions, you will need to go to this GitHub page, download this code down, or you can git clone it and open it in your text editor, which in my case, I'm using VS Code, right? Okay. So, yep. At the meantime, for anyone that already have these codes and also some data on your end, just make sure that you can activate it with a Python kernel. So you should be able to click here to select the Python version. So just in case anyone doesn't have the Python appearing here, when you click on the button, it should show you something like this. So in our case, we are going to use Python, and you can pick the version that you want. In my case, I will pick 3.11.9. Okay. So of course, the version do matters because it might cause some errors later if your version is too low or your version is too high, but just let me know. Okay. Because eventually when I was trying out this content just now, apparently the code that is provided from the workshop studio is for 3.8 or 3.9. So there are some deprecated functions which I need to fix it to make it into 3.11. Yeah. So just let me know if you guys already have the code. I will give you guys time at 8:39 to have that on your end. All right. You just need to open it here, and you should have this. Okay. So why Jupyter Notebook, right? Normally when you are working on projects that is related to data, or even like data science, even into like machine learning, most of the time you work with Jupyter Notebook because of the flexibility that Jupyter Notebook give you on the end, that where you can see your user interface. That is one. Because normally if you are doing it in Python scripting, you will just see the code, but the result will come after that when you run it. But in Jupyter Notebook, you can see the result directly. And most of the cloud computing tools out there, they allows you to actually upload your notebook. And by having the notebook with the output that's provided, it will be fit into the machine learning models later on. Like for example, AWS SageMaker, and in Azure that's possible as well by having the notebook online and make it into a model. So that's why we are using Jupyter Notebook. And also Jupyter Notebook is able to have you code in R programming language, Python, and also many other language with external tools, but by default they are able to access on R programming language and Python. Okay, so just some context of what is Jupyter Notebook, right? Okay, Jupyter Notebook. In the name itself, you can actually identify why it's able to run Python and R. I am not sure do they have it explained here, but in Jupyter Notebook, the Py is known as Python, the R is known as R programming, and the JU and TE is known as some of the items, but I kind of forget about it. But yeah, so that's why it's actually built for Python scripting and also R programming, right? So without further ado, just in case someone that just joined, you guys want to access the code, okay? Without further ado, we can start with our workshop today. So ensure that you have the Python version selected, okay? And then what I will need you guys to do is we clear all the output first, right? So today our workshop will be purely on data preparation. So it's more like how you explore the data and also some data cleaning and manipulation further on. So let's begin. All right. So the first code blocks here is eventually like the normal pip install, but in Jupyter Notebook, you actually need to make it into a command for your Jupyter Notebook IDE to be able to access to all of the libraries that you want to use later on. So let's run this code. There's multiple ways you can run the code like here, or you can use the shortcuts. You see when you hover to it, you can actually see that's a shortcut. And of course, you can run all together and you can execute this cell until the end of it. That's possible as well. But in our case, because we are doing it like a workshop sense, so let's make it one line by line, okay? Not line by line, but blocks by blocks, yep. So today, the packages that we are going to use is pandas, because you know when you are working with data and especially in Python, we actually need to change the data in a format where computer can understand, where commonly in the data field, we often make it into a data frame format, which pandas libraries can help us to do that. So that's why we are using Panda, and scikit-learn is more on the pre-built models that we can use, like the algorithms that is built by the developers out there. So we can just pip install and use it across. Where Matplotlib and Seaborn is more on the visualization, but you will understand why later we are going to use some visualization. Because normally when you are doing like data cleaning and data preparation, you actually need to understand your data like in a deeper sense. So with visualization, you can actually see it deeper and more context that you might miss out. So yeah, that's why we are using this. So once you run this, it will say like the requirements is satisfied. Okay, so it has already pip install of the package that we need to use later. And let's run the second block. Okay, before running, right, let's see what is the context. So just like a normal Python scripting, right, you might import the packages for use. And of course, inside scikit-learn, sklearn is actually scikit-learn. It's not only providing like algorithms, but it also provides calculations and of course some data sets that is somewhat like a sample if you don't have a sample data set to use. Okay, so in that case, we are importing pandas as PD. Okay, so it's more like a alias where we can use it as PD later. And sklearn, we are getting the data set that is on load IVs. So just some context on what is the data set about. So IVs data set, this is very common if you play with data a lot. I would say IVs data set is more like the first step into data when you are working on like tutorials and stuff. So what is the data about, right? Is about IVs is a flora, okay? It's a type of herbs where not like herbs but flower, okay? Where it has different species or different family, okay? So it's more like the type of the categories of IVs, where how do we identify the categories through the length of the iris. Let me just find visualization of it. Iris visualization on classes. I actually have a slides on that last time, but let me just see Iris on species. Hope it. Yeah. So this is the common family of iris flower. You can see there are different variations, and it's pretty easy to identify through the petal and the sepal here. So this is how we identify it, and with that being said, we can actually use computer, which is like AI, right? We can build algorithm to actually helps us to identify what is the category, what is the species of the flower itself. So let's run this code. Okay, basically it's saying that we are going to load the iris data sets and we make it into a data frame. So if we want to look into what is this data set about, okay, let's run this .info. So now this is actually a data frame because we have changed it into a data computer readable format. So you can see here, when we are running .info, we can actually see what are the columns that falls in the data set itself. There are serpentine, there are width, the length and the width, okay, of the petal, okay. And you can even see what is the type of the data. For example, in here, there's a float, meaning that there are decimals, right? Something dot something. And of course, you can see how many of the values are actually non-null, meaning that there are no empty values. Okay, now is empty values, right? So now we have explore like what's the structure of the data, and we can look into some of the data that is in it, but we make it like, for example here, dot head means that we are getting the data starting from the first one to the numbers that we want. So by default, dot head will return us with 5 numbers, okay, meaning that 5 rows of the data. So we can see the first 5 values that falls in the data set. And let's say you can see there's a like an exercise run. Yeah. So he's saying that if we wanted to show more, like we want to see like maybe 10. So how do we do that, right? It's pretty easy. Iris data frame dot head, okay, and a bracket. You just need to place the values inside. So for example, if I wanted to show 10 values, I just need to run this. You can see it's giving me 10 values. And of course, in Python, indexing starts from 0, right? So 0, 1, 2, 3, 4, 5, 6, and then 9, right? So these are the first 10 values that falls into it. If you wanted to see from the end of it, so we have here and we have here, okay? So this is the end. Counting from the end of the data that we have, it shows accordingly, okay? So now, of course, normally when you are working with data sets, you're commonly faced on empty values. You wouldn't always see like the non-null value. It will be like 0, right? Because in this case, like 150, and when we are printing the tier, we actually know that there are 150 and no values is empty. Like there are no null values in each of the columns here. So you will eventually need to deal with missing data. There are multiple ways, which I I don't think they cover all of the ideas here, but yeah, we will go with the ideas that is provided here first. Then maybe I will give some more suggestions later. So one of the package that we can work on the data manipulation or more on the calculations itself is we can use the NumPy. So NumPy is another library. It's called NumPy because of numbers and Python. So it can help us to work on the calculations. And fun fact is when you install the pandas, NumPy comes with it. Okay, of course you can just install NumPy if you just want to use NumPy. So let's explore this, right? Just assume that we actually have empty data. Okay, so what it's doing here is it's making an example data frame. Okay, not a data frame, a data series that has a value of 2, none, and 6 and 8. Okay, so when we make this array into this variable example 1, when we print it out, we can see, okay, yeah, the value is actually an array with the values of 2, 9, 6, and 8, right? So if we wanted to run a sum on it, okay, you can see there are errors. Why? Because there are none value. None is like a null value, okay? Null value means that it's empty value. So that's why it's returning us with an error in a sense. And of course, how do we work with it? Let me just we can actually replace the none value, or we can remove. Okay, so there are multiple ways. If you don't have enough data, okay, if you don't have enough data for that, you actually need to fill in data for the empty values. For example, you don't have enough rows for your data training, okay, because normally when you are training your AI, if your data is too less, that comes to the issue called underfitting, meaning that the data is not enough for the machine to understand the context and what is the best accurate predictions, right? So that's called underfitting, where when you are giving like a new data to the AI, it can't really give you the correct answer because he has too less data that they understand. For example, if you are training a baby to learn mathematics, right? If you just teach the baby on addition, but you're not teaching it, you're not teaching him or her subtraction. So in that sense, if you give the baby a subtraction questions, it don't know how to respond and don't know how to do it. So that's called underfitting. And overfitting is you are feeding in too many data, and the data that you're feeding in is too specific. Okay. For example, let's say if your lecturers is giving exam tips, maybe, right? If giving exam tips and your exam is about maybe software development life cycle, so your lecturer is saying that, okay, our exam will comes up with a lot of Agile and Scrum. So you just prepare for Agile and Scrum. And in the end of the day, when the exam comes to you, it's actually asking you about like waterfall model. So in that sense, you will keep on thinking, oh, okay, I have prepared for Agile and Scrum. So I will answer the question in Agile and Scrum methods and maybe the context of it. So that's called overfitting because you are feeding too many specific data to the AI. Okay, so data volume itself is very critical for you to identify. And how do you identify through it? There are some metrics that comes with the prediction itself. But today we wouldn't touch on the AI modeling part, but we understand more before the AI modeling, which is the very critical part, because with a best quality data comes with a best quality AI, right? So yeah, that's the context of it. Okay, so with that being said, now value we really need to cope with it. Okay, let's see. Okay, let's say there are some missing float values. The bad news is that always return in. Okay, so let's run this code. Okay, so you can see when null values, the reason why when you're running sum, okay, is when null values, okay, NaN is actually another context of saying a none value, an empty value in Python, which we are using NP, which is NumPy, okay. So the null value plus 1, it will always return you with a null value, and the null value plus 0, it will always return you with a null value. So when you are running a dot sum, you are getting errors because when you're adding everything together, at the end of the day, you are getting none, right? A null value itself. So, and when you are running sum, the Python scripting is assuming that you are passing all of the integer values. So that's why we actually need to work with that. Okay. So let's see what does the code does here, right? So he's going to do an array called example2 with a two null value 6 and 8, okay? And the first thing is running a sum, okay? And it's returning a null value, of course. And then when it's returning a min, it's return a null value as well. And max is null value as well due to the fact that we have this null value. So what happens if we add two null value? I assume this will return like now as well, but let me just try it ahead. Okay. Oh, it will return error. Okay. Unsupported operands. Oh, because I understand why it's giving this context. Okay. So the context that is giving here is when we are checking the type of this mp.nan, and when we compare it with the none, okay, none is actually giving us a direct error, right? It's saying like tab error. But if we are using like mp.nan, it will return it as a float value instead of giving us error. So that's none data type comes directly from the original Python. But if you are working with like data manipulation and stuff, it's very recommended that you are using data types that comes from NumPy. That's why MPNAN is somewhat solving it, but not actually solving it directly. So let me see, do they like juggle with the items here? Okay, integer series equals 1, 2, 3, d type equals in. Okay, so how to set it in equals to none. So for us to check, like, is there any null values in an Panda series, or is also known as an array in a Panda? So there are Panda series, there are Panda data frame. Okay, so data frame is a big structure where you have multiple columns, but series is just one of the columns, if you understand it like a more visualization way. So assuming that you have a data, right, a data in Excel, so you have multiple columns, then it's a big data frame, all right? And if you are getting a specific series, means that it's either a column, a single column, or either a single row, right? So that's called Panda series, okay? And if you wanted to check, like, is there any null, I think you just need to type like int series dot, let me just check, because Google search is your best friend, but of course you can use ChatGPT as well. So just to check the context of that, so pandas, check data series now. There are many functions that comes with it. Yeah, we are going to use is now, but let me just check. I think it's just is now, then that's all good to go. Yeah. Okay, so there are multiple ways. I think they gave the answer here as well. Okay, so is now, I hope this works. Okay, it will actually show us like in the whole Panda series, is there any null values? And it's saying that, hey, the first one is no, false, second one is false, means that 3 of the items in the Panda series is actually having values. And of course, you can play with it like finding dot not now, means that you are finding values that are having values instead of an empty one. So by right, it will show you the true. You can play with it. And drop NA is dropping the null values. Okay, let me just try it across. Okay, so it's pretty easy. You can just play with it. So for example, right, I place a null value here. Okay, yeah, because I specify the D type. If I do this, yeah, you can see I have a null value. So if let's say I run like dot drop NA, of course, for more features that comes with it, yeah, you can see I actually drop the NAN. Okay, so this is one of the ways how you can remove data. But if let's say you have not enough data, you actually need to fill in data. One of the ways that I often use is I actually get the sum of the full columns. Okay, I get the sum, and in a sense, I'm getting the median of it to fill in, or I find the pattern that comes. Let's say it's a time series data. For example, IoT, like your IoT watch, like Samsung watch or something like that, right? Apple Watch, it will keeps on like tracking your maybe heartbeat, okay? Maybe heartbeat. So with that being said, it's a time series, right? From 9 a.m. to 9 p.m. Okay. So for example, somehow on 1 p.m. Because I removed my watch, so in that sense, it's more reasonable for you to actually find the pattern that closer to 1 p.m. For example, from 11 to 12 p.m. and also 2 p.m. to 3 p.m. So from that data that falls within that, you can actually make it a sum and divide by 4 to get the average, or you can just sum it all and get the median of it. So you can actually fill in the data on 1 p.m. if that's the case when you don't have enough data. So there are some of the ways that you can work with it. Okay. Of course, if you have a lot of data, it's more recommended for you to remove it, but it really depends. It really depends. So that's why you need to explore your data properly. You need to discover what might miss out, where does this null values make sense, and if we have these null values, will it affect the performance of what we are going to do on the data analysis or data science pipelines or all of the stuff, right? So okay, so this is, yeah, it is doing what I did just now. So it's getting like 0 and MPNAN just to check the context of what falls in the array. You can see there's a 0, a null value, okay, and then empty string and a none value, okay, it's not empty. So when it's finding is null, you can see it's returning that 0 is false, because that is actually how Python identify true or false. So if you actually put 0, it will return false. You put 1, it will return true. Okay, so yeah, that is some context on how Python compute. And oh wait, sorry, it's now. So okay, 0 and 1, that's another context on the true and false, but this is checking is null value. So 0, apparently there are values, and this empty string, although it looks like nothing here, but it's actually an empty string. So it's still returning that there are values there. So that's why it's a false. Okay, and of course, MPNAN is a true because it's a null value, and none is a null value, of course. Okay, so yeah, it's asking you to explore more, like when you are typing not now, what you will see, right? Okay, and oh, so let's just see what is the result of it. This is very useful. You can see later, okay? So when I run this, you can see it's just returning me with the 0 and the 2, meaning that it's just returning me with this value and the empty string, okay? Which means that this is one of the way where you can filter out the null value, okay? And one of the way how you can juggle with the empty values when you are working on data cleaning, okay? And this mechanism comes with the data frame. So how it actually populates is we split it across, okay? So when you're running the first items with not now, okay? Let me just run this. You can see it's actually written true false, right? So with this true false, it's giving us with the index, meaning that if we just want to filter the values that is not empty, okay, you can just put the true false inside of the array of example 3. If you know how indexing works and how you can do filters on common arrays, you just need to specify the index, right? So in this case, when you're running this, it's already providing like the 0 index and 2 index. So that's why you can actually filter out the empty values, okay? So of course, that is one way. And the other way is just throw the arrays, throw the numbers away. But for this case, you need to be very confirm, because the previous case is you just filter it out, but you are not changing the original values. But this one is changing the original one, okay? Because it's dropping all of the empty values and feed it back to the example 3. So what it means is the first method, you still keep the original arrays. How does it looks like? It's still there. But the second one, once you run the computation, you can't actually revert it back. Okay, so these are some of the things that you will need to take note. And of course, in Panda data frame, it's not only rows and columns, it can be more dimensional, meaning that rows and columns is like X and Y, right? So it's like 2D, okay? It can come in the 3D, 4D, 5D, 6D, according to how complex is your data. For example, in this case, this is actually giving you a more in-depth because of the fact that, okay, the first, okay, let me just split it across for you guys to see what is happening here. All right. So you can see as a bigger frame is actually putting like 3 data. So assuming that each of these columns, right, is like 1, 2, and 3. But in this case, we can actually go into deeper of it because each of the 1, 2, and 3 is actually another dimension. So this is why we should use data frame when we are doing like data cleaning and data preparation, and even like further on you are doing like data science, data pipelines, and maybe machine learning models. That's why data frame is very useful because of the fact that you can go into like many dimensions of it. Okay, so you can see now it's like giving you data that shows like this. Okay, and of course it can work with the job NA as well, but in this case, as you see that this first row and the third row is providing empty values, it will just fine for everything that has empty values. It will drop everything. So in that case, it will only remain the second line of it. And due to that, with this less amount of data, if you wanted to do some visualization and you propose to drop everything, you will only have one row, right? So that is not very good on the analysis part. So this is why I keep on emphasizing that you need to really understand the data and what you are going to do later on. Is it good for us to drop it? Is it good for us to remove it? Or is it better for us to actually place some data into it? Okay, so that's something that we will need to take note. And of course, this drop NA is on columns. So for example, right, let me just run this. Okay, let's see, axis 1. Okay, so the example 4. Okay, now when you are printing it, it's giving you like a rows and a columns. And normally when we are dropping like the drop NA function, it will drop the rows, right? So we can actually change how things work by changing the axis, because you can understand this as a X and Y axis. So X is here and Y is here. Okay, so on the right side, and this is the X. So with that being said, when we change the axis, and of course, if I'm not, I didn't remember wrongly, you can replace it with a 0 and 1. Of course, yeah. So 1 is similar to, is same as how you do the dropping of the values, okay, but on columns. So 0 supposedly is how you can remove it on the row, okay. Of course, for more like documentations that you want to see how does everything works, I will highly recommend you guys to go to the official documentations. Maybe you can just go to Cloudy or ChatGPT to generate the code for you, but most of the times it's really better for you to come to the official documentation due to the fact that they are providing more context to it, and the context, I would say most of the time, okay, most of the time is correct. So, and they will also give you more suggestions like what are the parameters that you can play with it, right? So these are some of the items that you can look into, okay? So official documentation is always, I would say always better than LLM, because LLM is just predicting. So yeah, okay. All right, with that being said, let me just see what does this third code does. So just like how you play with a normal array, okay, just like how you play with a normal array, you can actually append a new row to the data that you have, okay. Like for example here, he's saying that, okay, I want on the index tree, means that the fourth value I wanted to put all of the null values. And of course I can make it into a array as well by having it to a panda.series. And then let me check the syntax. Okay, so for example, I want to put like 1, 2, and 3. You can do that as well. You can see now it's 1, 2, and 3. Okay, some of the ways that you can manipulate with the data by playing with the columns and the rows. And this one, I guess I will leave to you guys for you to explore how to solve it. Okay, and I think this is the somewhat the answer to this. Yeah. Okay. So as I mentioned, on the drop NA itself, right, you can drop columns and rows by specifying it. But by default, it will drop the rows, because as we try just before that, it shows that it will drop the row by default without specifying it. So in this case, it's actually dropping the rows. And trash tree parameters actually give you a fine-grained control. So we set the numbers of non-null values that are okay. So what it means, right? By having this, you can specify like when I want to drop NA, I just wanted to see the column of 3. Okay, so when it's checking the column of 3, it's actually finding like, hey, all of the values are actually there. There are 1, there are 2, there are 3. So we don't need to drop anything. Okay. As you recall before that, when we drop NA, we can't actually control what are the columns that we want. So for example, if I drop like the trash on 1, this row will be removed. The 1 NaN 5.6 because it detected NaN. Like just try it. Oh wait, sorry. Oh yeah, 1 is here. Oh sorry, because it specifies rows. Okay, so if I put like columns and run it, why is it not? Let me check the official documentation. So pandas drop NA. Check on this, and let's see trash. No default. So trash because many non-NA. Oh, okay. Can I be combined with how? So in our case, for each of the columns and the rows, it only has a one NaN. Trash is specifying like how many non-value must be there. So with that being said, when we are putting 1, it wouldn't be moved. When we are putting 3, because just now it's specifying rows, and supposing rows only have 2, that's why it's not removing. But just to test the context, I hope it works. Oh, it doesn't work. Okay, I guess I'm wrong for the theory of this, but let me just see. Is there any example that they run it here? Okay, drop NA, NAT. Oh yeah, it's correct. It's correct. I think it's correct. So if let's say I do this, because on the official documentation it's supposed to be correct, but just to see the context of the things here, right? So for example, if I put another column here, and I wanted to find on the columns, okay, with the trash of maybe 1. This one is putting 2, and it's dropping the rows. That's why it's dropping this first row due to the fact that they have 2 null values. But I'm not sure why it's not working on here. Let me just try and see. Series. Okay, PD series, and let's just put like all of it as a null value. What is it? mp.nan. Yeah. Okay. So we print it out first to see what is it in on the array. And when we drop NA, yeah, you can see it remove it, but because it's too fast, let me just run this first. Okay, so before we drop it, you can see there are columns that has like more than one null values, right? So it's supposed to remove the final one. So when we run the job NA, okay, it remove it. Okay, so that's the idea on working on trash. And of course you can drop the null values according to the subset, meaning that for this case it's structured in a more readable format by saying that, hey, this column is a name, this column is a Troy, this column is a Bond, right? So that's some of the things that you can play with it. Like you wanted to specify how is it you wanted to remove the any or all of it, okay? And they have like a very detailed explanation, and of course they have example on how it's being implemented here. So by having this is really easier for you to understand, because they have all of the parameters that you can play with it on the official documentation, and of course on how the sample will looks like when you run it. Okay, so that's why I always really likes to refer official documentation. Okay, of course Stack Overflows helps a lot as well. Yeah. All right. So the next one is finding null values in, yeah. Okay. This part is we are going to fill it in. So as I mentioned just now, there are two ways you can play with it, right? Either you fill it or you remove it. Okay. So the previous one we learned how to remove it by having a drop NA and everything. How do we specify all the parameters and stuff? And now we are going to learn how to fill it in. So in our case, they are giving an array called example5, which is a panda series array. Okay. And you can see there are empty values on the B and empty values on the none. Okay. The reason why it's showing A, B, C, D, E is because of this. They changed the index. Okay. Normally index 0, 1, 2, 1, 2, 3, 4, right? To a list with A, B, C, D, E. So when you are putting list on a string, it will actually split it. So for example, if you want to customize it, right, you can actually make it like maybe the first one is name, second one is name one. You just put random stuff like description and yeah, maybe C and D. So when you do this, you can actually see, yeah, the index will change according to what you specify here. I'll just make it to the default just in case they actually specify like A, B, C, D, E later. Okay. So one of the way you can fill the null values, okay, you can fill in with a 0. So fill NA, just now we learned on drop NA, now it's fill NA. So filling the null values with a 0, you can see it fills with a 0. Yeah, that is one of the ways as well, filling with a 0 values. But you will really need to understand your data, and you will need to decide which is the methods that you wanted to fill in, either a median, an average, pattern-based median, or AI calculated prediction values, or maybe put a 0. Okay, so that's what you really need to see. Normally when we need to put a 0, I'll give you an example. Is for example, okay, for example, APU, before, I just assume the years because I'm not sure when APU is established, but let's say it's established on 1970. I think it's more later, but it's established in 1970. So we are plotting the data analysis with the data that we have, where some of the schools actually established on 1960. So they have data from 1960, but APU starts from 1970. So in that sense, they have now values from 1960 to 1970 due to the fact they are established on 1970. So that makes sense for you to actually put a 0 values instead of putting an average. Okay, so some of the context, you really need to think through it according to your use case. Okay, so these are some of the parameters that you can play with. For example, this with fill NA with a method of ffill, it will actually find for the last valid values. Means that in our example here, right, the last valid values before B is 1.0, and the last valid values before D is 2.0, right? So you can see now is, oh yeah, correct. Now it's finding like the last valid values and you fill it in. Okay, And of course, B field is back field. So you will find the last valid values that comes after it, right? These are also some of the ways you can fill in the data. And how does it work with data frames, axes? Yeah, I think we can see this. Okay, so this is first field. As we know, you'll find for the first last valid values. And if we change the axis, okay, if we change the axis, it will actually, okay, before running this, let's just see what does the data looks like. Okay, this is the example 4 that we played with just now. Okay, and you can see that we have multiple null values here. When we are filling in the null values and you are changing the axis to 1, means that it will fill by the column. So what does this, wait, axis to 1 is column, axis to 1 is, wait, let me just try. So let's say we fill it with 0. 0 is according to last values that comes from the row. Yeah, correct. Yes, my theory is correct. Okay, so comes from the row. As you know, this is the first row, right? The first row, when this NaN is referring to the row that comes before it, it's not seeing anything, right? So that's why it can't fill anything, and which happens that the fourth column here, it will just keep on filling the first field, right? You just keep on filling NaN because they can't refer to any values. But in the sense of this, it can find the 2.0, that's why it's filling at 2. So if we fill with column base, okay, so it will find for the last valid values that comes from the column before it. So in this case, it's finding for 1 and replace with 1, 2 replace with 2, 3 replace with 3. Okay, cool. All right, yeah, exercise. I guess we can go with this. So let's say if you want to fill in with a mean value, okay, you can just go with example 4.min. And of course, in the fourth column, it can't really calculate a mean because all of the values are 0. So that's why it can't fill with anything. But you can see here for the 1 and the second one is actually getting a mean value from the 1.0 and 2.0. It plus together and divide by 2. That's why it's getting 1.5. Okay. So these are some of the ways. And of course, there are more ways like getting the Q3 and the Q1, or getting the average, or wait, actually mean is average. Yeah, mean is average. Or getting the median of it, or AI predicted, which I think most of the time, like people will refer to AI predicted more nowadays. So yeah, that's some of the ways of it, but I don't think they cover it here. Okay, they don't cover it in the context because they are quite long comes after that. You can see there are some visualizations that comes after that. Okay, so let's continue with the content here. So of course, removing duplicate data is very important because we don't want redundant data to make it into overfitting. Recall that when I'm giving you the scenario where lecturers are teaching Agile and Scrum, but the exams comes with waterfall models, right? So that is where overfittings comes because it's keep on feeding you somewhat called duplicate. I don't think this is the best scenario to explain that. Let me think of one. Okay, for example, the school face recognition data. Okay, the school face recognition data. Wait, this is not a good idea. So, okay, for example, you are working in a company, right? A company has data of the profits across the year, right? Profits that comes across the year. So they want you to actually do a data visualization and storytelling. But in that sense, you actually has a lot of data that is somehow duplicated on the month of July. Okay. So when you're plotting data, if let's say we plot it in a heat map or something, because heat map is plotting according to the frequency. So we can actually see like a lot of data falls on the July, but the others is like 1 or 2 data in the other months. So that is why we actually need to remove duplicate data, but we really need to justify that is it duplicate or is it another unique data that somehow falls in the same time or somehow falls in the same category? Okay, so that's some things that you might need to keep in mind. Okay, so let's see how do they do on the duplicated data. Right, so now assuming this, we have a data frame and the letters A comes with number 1 and the letters B comes with number 2 and B with 3, A with 1 and B with 3. So we want to check like what is there any duplicated one. So when you're running this, it will actually somehow loop through it, but it's not really running in loop because as you know, when we are working like in your data job or in your software job eventually, we will try to prevent loops due to the fact that it will cost us a lot on the computation and of course the time, especially when you have a lot of data. So normally they will use like more external tools that can change it into a binary form or some external package that can work on that easily. So that will actually helps you to do the looping more easy and cost your company computations lower because nowadays most of the things are on cloud, maybe on-prem as well. So in that sense, they will want to minimize the computation as much as possible due to the fact that you need to pay. Okay, so when you are finding this duplicate, it will somehow look through it and it will find for is it duplicated. And of course, when it looked the first one, no, because it appears once with the A and the 1. And on the third one, it finds that, hey, A and 1 actually appears before, so it's returning that 2 is a duplicated one. And B3 appears first time, then the second time is a duplicated one. So in pandas, we can actually just drop duplicates like this, okay? Oh, actually, I have a better scenario to explain like duplicate data. Like for example, you are selling t-shirt merch, okay? T-shirt merch, and somehow some of the customer they fill in the form like twice, but they only purchase once, right? So in that sense, it might has like 2 L size shirt for this specific person, but he only pay once. So if you don't duplicate the data, you don't remove the duplicate, you will manufacture over the amount and it will cost you, right? So that's why you need to work on the duplications because data itself is not only for like data analysis, data modeling, AI, but it's also for people that works on the business in IT for operations, right? So these are some, I would say Python really helps you a lot on how you can do the scripting easier. So yeah, okay, so this is how you can drop duplicates, and of course you can drop duplicates according to the specific column. So for example here you can see it's dropping the A and B because we are specifying that, hey, I just want to drop the letters. So in that sense, it will only give us the first appearance of the A and B. It wouldn't comes like the final appearance of it, okay, as you can see here, right? And of course, just to test it around, you can just drop duplicates by the numbers. Yeah, you can see now it's returning like 1, 2, 3 because 1 appear twice. It removed the index 2, and 3 appears twice as well. Remove the last one, as you can see on the index here, right? Cool. So the next thing is combining data sets. Let me get some drinks. Okay, a bit thirsty. Okay, I will be back as soon as possible. All right. All right. So sorry for that. So let's continue. So why we need to combine data sets is the fact that most of the operations or most of the companies, when you actually enlarge your company size, right, you might use like different tools to collect your data. For example, you might use Azure Databricks to collect data, and maybe you are running another MongoDB instance for another system. But when it comes to the end of the month, you want to do some data analysis. You want to see like how your company is doing, right? So in that sense, you actually need to combine the data sets. But there are many ways that you can combine either by ETL or ELT tools. But in this sense, is for data that maybe you have downloaded everything and you can access through a CSV file or Excel file. You can actually use pandas to do that. And of course, you can do some Python scripting to actually make it into a data frame and combine it together, right? So this is some ways that you can work on the combination. So the first one is doing a data frame one with employee and group, and of course the employee name and what's the employee department falls in. And data frame two is also the employee, but is finding for the hire date. So in this sense, we can actually group these two data by the name, okay, and also placing the group and add with the hire date. So it will cross-check on the name and put the date into it. If there are no group, maybe we can leave it empty, but there are ways to actually work with that, okay? So let's see, when we merge it up, can see it finds for the specific name, okay? For example, Mary is from, she's hired on 2008, and the group is marketing. So when we combine it together, you can see now is just as this. So it's pretty easy. When you just run like panda.merge, the data frame will actually, it's pretty smart. Like it can identify like what is the things that you wanted to merge. And oh, sorry. Someone unmuted, I guess. Okay, cool. Yeah. So it will help you to work on that. You know, like normally when you are using like SQL itself, you actually need to specify like join from what column to what column. But in pandas, it's possible for you to just run a pd.merge to find the pattern. But you are able to specify that as well, if I'm not wrong. Just check the official documentation. So pd.merge, right? Okay. You will be able to see like when we are merging it, okay, left on left key, right on right key. Yeah, and you see this left on right on is actually specifying the specific column. And actually many more like validate indicator. You can look into it because there are really a lot of parameters when we really want to dive deep into it and we wanted to make it more customized, right? So yeah, these are the ways. And just now is one-to-one. Okay, as you can see, Mary is to Mary. But now we are going to explore like many to one, right? So many to one, the group and the supervisor. The reason why it's many to one is the group, as we recall, it appears multiple times, right? Marketing appears 2 times. So with this data frame, we wanted to merge it with their respective supervisor. So when we run this, Pandas is smart enough to identify the relations and place the supervisor accordingly, right? Can see it's a many to one. And of course, on group, this is where you can specify like how your merge wanted to be, right? So on the group itself, merge it up, the result is the same because of the fact that the data is the same when we are grouping. Okay, but just in this sense, you can actually customize it to say that, hey, I wanted to group it on the group column, because assuming that maybe your second data frame, you might have a group and the hire date and the supervisor. But in this sense, maybe the hire date is more reasonable that it's the supervisor hired into the company date. So with that being said, is very important, like why the customization is there for you to specify which column you wanted it to join. Okay, of course there are many to many, so we just run it. I guess it's very straightforward on this. Yep. And left on, right on, yeah, this is what we saw in the documentation just now, right? So left on, right on, let me just see, right on name, on left on, what's the data frames that it combined? Okay, let me find for DF1. Okay, open a new code. I want to see DF1. Okay, so DF1 is the group with the specific employee, and DF6 is the name and the salary. So when we are merging it, it's saying that left on employee, right on name. So it's placing the name to the right side, I assume, and then the left side is the employee. So that's why the result comes with this. Okay. Because exercise, I think I will skip that because that's quite lengthy when we go into deeper down. Okay, so this is setting the index. So assuming you don't want your index to be like 0, 1, 2, 3, you can actually change the index into your specific column. Like for this case, they are changing the index into employee. So now the employee will be the index. And when we wanted to use the specific index that we have specified, I assume it's like this. Let me just get, for example, I want to access Gary, right? So let me just try this. Oh, sorry. Let me see. Okay, maybe it's. I think that's the get index. Let me just quick check. Yeah, Google search is really a best tools when you're working. Then you know that Google search and like some LLMs that give you like very specific stuff is like really good. But prompt engineering is really it's very important as well. Because the way how you answer will eventually affect the quality of the answer that you want. So in this case, I wanted to use pandas to get index. Okay. So it's getting the dot index of, oh, this is changing the index. Get index of a row. Oh, yeah, sorry. Get a row by index. Yeah. This should give me the correct answer. So when I'm going, yeah, we can actually use iLoad. iLoad is lookup of the information according to index. Okay, as you can see now, this dot iLoad is go with 2, right? So meaning that it will returns you with the 0, 1, 2. So it will returns you with this, okay, with this index. And if you wanted to find for the lookup of the specific index, like for example here is finding for 2, so it will respond it with a 2. Okay, so there are 2 ways. Okay, I think it covers after this as well, but yeah. So we can, let's say we wanted to get Gary. Okay, so you just go with a dot log and oh, sorry, Gary, and when I run this, it should oh yeah, sorry. Yeah, syntax matters. Yeah, I can see it's returning me with Gary and the group of accounting. So if we are not sure what is the index that we want, but we are very confirmed with the, no, yeah, we are not sure of the name of the index that we want, but we are very confirmed on the index of the array. So we can use I means index, and lookup. Maybe I wanted to get the third 0, 1, 2, 3, so it's the 4th item. Okay, so I run this, it should give me the 4th item, which is Sue on HR. Yeah. Okay. So of course, the F2 set index, I guess this is going to, yeah, it's teaching you back on the merging. Okay, how you can merge on the items that we have on the DF. Okay, so it's finding for the employee and put the group first, and after that put the right index, which is on the higher date. Okay. All right. Exercise. I guess I will pass that. join. Join is another way of merging as well. Okay. Then merge left index true name. Okay, set arithmetic merge. Oh yeah, this is teaching you like, you know, like inner, what, left join, right join, uh outer left join, inner join, right? So this is how you can specify that. Okay, and okay, this is left join. Maybe I can explain a little bit on this in case anyone is like not familiar to SQL. Okay, so inner join, if you find for the values that both of the two tables that we have, okay, we have two tables, assuming this, okay, which actually means that when you are merging, you have two tables, right? In data frame, it's the same as well. So these two tables, when we are doing inner join, means that these two tables must have the respective data to make the join happen. Then it will only has the data that comes with it. So in that case, if we are looking into DF1 and DF5, right? DF5, it has engineering, marketing, and sales. And DF1, let me just print it again. The code, DF1. And DF1, it has accounting, marketing, and HR. So with that being said, it will return me with marketing only. Okay, so we are going with inner join. You can see it's returning us with marketing only, right? Marketing, writing, and writing, because in these two correlations, right, the same values that it has is only marketing. So with the same data, because I think the below is actually running like left. Oh yeah, they are using the same data, is good. Okay, so with the same data, if you are going with left join, meaning that it will focus on the first table that comes on the left side first. Okay, it will print all of the data that we have on the left side, and it will only see like, is there any right items to fill in. So with that being said, when we go with a left join, okay, is giving us like all of the data that come on the left. It doesn't really matters like what is the data that come in the right. If there are data, it will fill in, right? Okay, so yeah, I don't think they cover right join and everything, but you get the idea, right? Okay, cool. So dealing with conflicting column names. Okay, we have a name and a rank, and we have name and a rank on the F8. Okay, so when we wanted to merge this, you can see because of the fact that these two column and pandas by default, they think that we wanted to merge on name, but of course you know that you can specify, oh, not by default, because we specify it. So in this case, if we specify that we are going on rank, you can see it's populating two names. Due to these conflicting names, it will appear on this kind of thing. So how do we work with that when we are merging it? Okay, of course you can change the naming of it to rank left or rank right, or you can do more complex calculations on the first table rank and the second table rank, and maybe make it into a sum and divide by 2 to get the average. That's possible as well, but I don't think they cover it here. Yeah. So yeah. Okay. So that's how you can deal with conflicting. Okay. And then concatenation. Concatenations normally more on combining it, but it's not really merging. Okay. So you can see here when we are combining like these three arrays, we just need to run the numpy concatenate. So it will make it into an array of all of the items that we have here according to the sequence that you place. And two-dimensional array, you can do concatenation as well by running the concatenation with specifying, no, I think by default it will just merge the row, but yeah, I can see when it's merging the axis one, right? Let me show you like how does this look like. Because by seeing the output itself, you might not understand how context works here. So let's say I have 5, 6, and because it's two-dimensional, so I can put like 7 and 8. So with that being said, by default it will merge on the row. Okay, so let me just show you. By default it will merge like a normal one. You can see here like 1, 2, 3, 4, 5, 6, right? And this one it will merge like a normal one, 1, 2, 3, 4, 5, 6, 7, 8. But if you wanted to merge like, okay, this first row and the first row of X and first row of Y supposed to be in the same index, so you can actually specify the axis. Okay, so axis equal 1 or axis equals columns. I think both works. Oh, axis columns doesn't work. Okay, my bad. Okay, axis 1. Cool. So you can see now it's combining it according to the column itself, right? Okay. Then the next thing, concatenation on pandas, because the previous one is on NumPy. So what if we already convert the items into panda series or panda data frame? So it's pretty easy. Just pd.concat to make two of the items together, right? And of course, now it's going to concatenate in a two-dimensional one. Okay, it's similar as well. And of course, the axis is here for you to concatenate it in a different way. For example, in this sense, by default, it will concatenate the rows, right? And ignore index true means that for the index that comes after that, it will populate according to the previous one. Okay. And of course, changing axis, you should see AB, AB, and CD, CD, supposing. Yep, there you go. Okay, cool. So concatenations with joins. Okay. So let's see. Okay, A, B, C, B, C, D, and join with inner. Okay. So just now we explore how we can merge data and like inner join, left join, right? So that is possible for us to apply it to concatenation as well. So when we run the join inner join, right, as we recall what we learned just now, inner join, it will only shows the result that both of the sides have it. So concatenation, when we concat this, it actually finds that let's see, df10, df11. Okay, it finds that A, B, C, and here is B, C, D. So that's why when we combine two together, the first table doesn't have D, it refers with a null value, and the second table doesn't have A first with the null value. So if we go with inner join, it will only show us with the BC, and of course, axis is here. If we wanted to do it in another form, and we index, oh, sorry. I think this is the deprecated code just now that I'm trying. Yeah, it's deprecated. So now it's supposed to be running as this, but I think just now it's not giving me the values that I want. We index df10. What if I try this, the columns, we index, I guess it's fine. Okay. It's not okay. I will leave this until the end if we still have time to solve this. But this was how you can work with Panda on the concatenation on the axis. I think it's on the version of 3.8 or 3.9, but I'm using 3.11 in this case. So the code is different. Okay, and it's giving me something weird, like all the null values. Yeah. Okay. And of course, you can append as well. Let's see, does it work? Yeah, append is an old type of how you can do that. I don't think append is possible now. Yeah, data object has no, data frame doesn't have it anymore. It's deprecated. So in that sense, you can just go with the pd.concat to do that as well. Let me see, is there any alternative for us to do it in a newer version of Python? Okay, so what is this? Data frame append. Okay, It's 1.4.4. Yeah, it's deprecated. Let me see, is there any like newer version? I think this function is not there anymore. Yeah. Okay, concat append. Yeah. Yeah, it's asking you to use concat apparently. Yeah. And if we change it to the latest version, I think I'm using 2.1 instead of 2.2. Yeah, it doesn't have the join. It doesn't have the join anymore. That's the append anymore. That's why I can't see it. But yeah. So this was how you can do it previously, or you are using an older version of Python, you can actually run the dot append. Okay, so yeah, that's the context of it. And if we run this, now we are going to use the data that comes in the comes with the code that we have, right? So it's a housing data set. You can see here. Just for you to understand more on all of these short forms, there are a very specific explanation for each of the columns, okay, for all the short forms. So if you want to look into details of it, you can go into it, but I don't think the time allows us to do that. But yeah, okay. So basically, these are the values that specify what is the somehow like characteristic or like attributes of the specific housings. Okay, so you can look into it like how many students and teachers are there in the town, and lower status proportion of it. Okay, so this is how we can see what is the data that we have. When we run df.shape, it can actually shows us like the total numbers that comes in the dimensional. For example, 506 is the rows, so it's saying that we actually have 506 rows, which is true. Okay, 507 minus the column's name. Okay, so it's 506, correct? And it's saying that we have 13 columns. So as you can see here, yeah, we actually have 13 columns when we're printing it. Yeah. Okay, cool. So we can go with a describe as well. I would say these are the normal ways, like how you, the first step that you need to do to understand what is the volumes and how does your data looks like, the df.head, df.info, right, df.shape. So these are things that you can go with. Df.describe is doing doing certain calculation on each of the columns. So as you can see, it has a count, a median, STD is a standard deviation, a mean, 25% is Q1, quartile 1, and 50% is median, 70% is quartile 3, and max. Okay, and of course, if you want to get the mean, can do it, which is what we learned just now, right? We are mean, finding the max of it, and getting the median. Okay, of this, and you can get the mean as well. You can get a lot of things by, you can refer to the documentations, what is the possibilities of the functions that can comes after a data series. So yeah, these are the things that you can do. All right, cool. So next things, yeah, in case you guys want to try this, it's pretty straightforward. So you want to get a max of the age. Okay, so you just need to go with the, okay, as I mentioned, data frame is a big table, and when we specify the age, meaning that we are getting a specific column, so it's a data series. So on the data series, I wanted to get the max, and voila, there you go. Okay, the max is 100. Cool. All right, so the next thing is on group by the age. Okay, by grouping by the age, I wanted to get the MEDV mean. MEDV, for more context, is the median value of owner occupied homes in $1,000 as, it's a square feet, I guess. Yeah. Okay, so yeah, this is how you can calculate the mean according to the grouping of the age, which this age is not the age that we know. Okay, proportional owner, yeah. Okay, so it's according to the age of the housing prior to 1940. I think it comes after 1940. Yep. Okay, 1940 year. Right. So this is the values, like how you can group by and do the mean or max. Okay, so this is some of the things that we can apply. And of course, if you know Python, there are two ways that you can do functions. Like one is DEF, by defining a function, right? And another way is a short lambda function. It's a shorthand function. So lambda, if you know like JavaScript, TypeScript, or even what else? That you can actually do like shorthand functions in your code. So lambda is a way where you can do the shorthand functions in your code as well. So you wouldn't need to like define another function to do that. Okay. So yeah. So this one is actually finding for the data that has the housing age that comes bigger than 50 and specify a new column called df, called age 50. So when we are running df, right, you can see we have a new column called age 50, okay, and it's a true and false, right? So true meaning that the house is like 1940 plus 50, so it's like at least 1990 until now, maybe. Okay, and then the false is apparently lesser than 50, so it's closer to 1940, right? So value counts, this counting the values, of course, mean, okay, and group by. You can see you can actually group by multiple of the columns instead of just one. Okay, if you understand the context of how SQL works, when you are doing some calculations, you might want to group by a specific columns. For example, you are counting like how many apples and how many orange do you have, right? So you want to group, you have multiple like apple 1, apple 3, then apple 4, then maybe orange 5, orange 10. So you wanted to get the sum of the items. So that's why there's a group by, right? So these are some of the ways you can work with it. And okay, let me see, is there anything? Okay, unstack. Let me see what is the context. Okay, let's say okay, wider format. In this case, you can unstack the data in a wide format. True and false. Let me just check the context of it. Okay, pandas unstack. Having a new label. Oh, apparently it's a pivot. So pivot is somewhat like a data manipulation on how your data should look like. Okay, and it will have like a new level of columns. So I'm not sure like how many of you is familiar to pivot. Pivot is very common in Excel, where you can change how your data looks like and how your data will be represented. And with the new data representation, you can do more advanced stuff to it. So yeah, you can see like dot pivot, stack, and dot unstack. So with that being said, you can actually see what, like, make it into another representation itself. But of course, if you wanted to see like what is the ideas of why the code that is running unstack here, you can see there's a very long description here. Okay, so for whoever that is very keen on like data analysis, I would highly recommend you guys to like read the context of it and how do the, because data preparation normally is done by data engineer. So if you are a data engineer or maybe you are a data analyst in smaller scale company, you might want to do data cleaning. So I would say reading of this context will really open how you understand your data and how you want to approach to your data. So yeah, you can definitely look into it and how they approach with this scenario that they want with an unstack. Okay, so yeah, there are some context. And non-unique. Okay, there are two. How many uniques? Okay, n uniques is finding for the uniques. Let me see. Unique values a column has in it. Okay, and then we'll likely want to know. Let me see what do we have in the CHAS. Okay.
Dari ada yang nikahin. Iya sekarang prioritasan ke sana nikahin dengan pilihan.
What? Okay, let me just mute. Okay, cool. Right. So the value that we have here is apparently 0 and something. Let me just get it from the head until maybe 10 of the head, because it's actually telling me that there are like 0 and from raising from 0 to 1 point something, okay, or 0 0.0 and 1.0 only. But let me just see more context on what is CHAS. Charles River dummy variable, so it's equal 1 if track bond river. Oh yeah, so I assume that this is maybe the housing is closer to Charles River, I guess. All right, so apparently the data that we have is only 2 because it's only 0 or 1. Okay, so as you can see, when we are running the n unique, is providing us saying that you have 2 unique values, and dot unique. Okay, all right, n unique number of uniques, so it will give us a total of the number of unique values, and dot unique will give us the list of the unique values. In this case, it's giving us like 0 0.0 and 1.0. Okay, right. Okay, value count. So we want to check how many are there, like the unique values, and on 0 0.0 there are 471, and 1.0 there are 35, right? And okay, now comes to a more fun part, because you can see some visualizations. Recall that just now we actually install Matplotlib and also Seaborn. These two packages for data visualization. Okay, so in Jupyter Notebook, if you want your Matplotlib to appear directly underneath here, you need to specify that, hey, I want it to be inline. Or else, if you don't specify this, it might appear as another window that pop up. Okay, so we specify that, and we go with our values count, and we plot it in the bar chart. Okay, so when you do this, yeah, you can see this, it has 400 plus apparently, right? 471, and 1.0 it has 35. So you can see like this is how the chart looks like. And visualization is very important on data discovery. Like it might helps you to identify, is there any what is that? That's a terms for the items that, let me find. Okay, data that is out from the box plot. That's a terms. I forget what's the terms. Value outliers. Yeah, it's outliers. So by having visualization, it's very easy for you to, like, maybe you can do a box plot. Like this is a bar chart, but box plot is another thing. So you can see what is there any very big outliers that falls like outside of your. Let me just show you how box plots looks like, right? Because it's easier with some visualizations here. Okay, so box plot, it looks like this, right? So this is where the median is. Q3 is here, Q1 is here, and of course this is the full range of where your data is. Okay, and normally data that falls like very far from the box here, it's called outliers, and it will affect, if you're doing like analysis itself, it will affect already. And of course, in machine learning context, it will affect more because of all of these outliers that falls outside. So that is where we actually need data preparation. We might need to remove the outliers, and of course the null values. So yeah, this is the context of it. Like for example, in this box plot, you can apparently see that these dots actually falls like very far ahead from these box plots. So we can identify this as outliers and remove it accordingly. Yeah. So yeah, data visualization is part of the data preparation, of course, right? So now we wanted to see correlation. Correlation is more like how each of the columns that you have relations to each other. How are they clashing on each other? For example, right? If you are running IT shop that you sell maybe, let me think, Wi-Fi router and computer, right? And you have a data that has the profit of it on each of the day and month, or maybe each of your branches that you have. Okay, so with the profit of the Wi-Fi router and also the computer, you can actually see the correlation. Like, maybe I will assume, right, if we have the data, for people that like buy computers, they will definitely need a Wi-Fi router. So in that sense, you can see a correlation is the computer values that is having the purchase and the Wi-Fi router purchase will be similar. Okay, I'm just giving some examples here. So data relations by correlation is very important. So now they are doing df.core is finding the correlations of it. Okay, and of course you have that called Pearson and getting that, but this is not very easy for us to like understand it better, right? Because of the fact that this is just numbers. But for people who are like very keen on data, you will really need to understand like what correlations means and what does this negative mean. If it's 1.0, what does it mean? 1.0, it means like the correlation is very high, if I'm not wrong. Because as you can see, CRIM and CRM column is having 1.1 because the data is exactly same. So it's having like a very high correlations. And negative, I kind of forget about what is the context about that. But yeah, you guys can look into details of that. But in this workshop, you will see like how to do the correlations and eventually how do we make it visible. I think there should be some plots that do the correlation, because normally correlations, there are multiple ways that you can work with it. Either you can do a scatter plot. Okay, let me just show you how the scatter plots looks like. Okay, this is how scatter plots looks like. Okay, so you can see like somewhat like a correlations that you have to it. And I think in this case they are showing, they are using heat map to do it. So heat map is another way where you can see like the correlations, like the very high one, the 1.01 is like completely black, and then the lesser correlation, the lesser clashings, the lesser relations of the data, it will be lighter values, right? Okay, so let's see, the next thing is histogram. So histogram normally it will be used on numerical values, of course, because you know there are, for data there are quantitative and qualitative data. Quantitative is numerical data, and quantitative is like maybe you are getting the feedback from your participants of your workshop, right? So that will be in the form of text or in the form of string. So that is quantitative data, but qualitative data, but that will be useful in analysis as well, or because there are some algorithms that you can work with it, like vector machines that can make each of the text into numbers, that with these numbers the algorithm will be built and the algorithm will act accordingly. So that is commonly used on NLP, natural language processing, and also vectorized text is one of the basis of how you can build your LLM, right? Large language model, which is the ChatGPT that you're using right like nowadays. Yep. Okay. So this is histogram. I guess most of you should know what is histogram through your secondary school, right? So, and also histogram, as you know, you can plot according to the beans, right? Okay, so the beans is eventually how far you want the items to be split into, because by default it's like 20, 40, 60, 160. So now you split the beans, means that you make it smaller by saying that my 5 is 50 of the bean size. I guess is it correct? I think that's correct. I think that's correct. Okay. Yep. Right. So it's how you can make your histogram more detail into it. no, it's wrong. Okay, 50 is actually splitting this into like you assume that by default it's giving us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 beams. Okay, but your boss is saying that, hey, I wanted to know more into details, like how does the 11 is doing, right? But in this case you can't really tell because it's only 10, like 5, 10, 15, 20. So by splitting that into beams, you can see it's going into more details, right? 50, so it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you can tell, oh, 11 is actually around like 6 or 7, right? So this is splitting the beams. And this plot is the combination of, what is it called? That's the name to that. I'm not sure, do they include that? Yeah, distribution plot. So distribution plot is a combination of the histogram and also a plot that shows the pattern. And this plot itself is commonly used when you are finding for the patterns of how your data is running through. Okay, because with this line you can apparently see a pattern of, like, even in stocks, right? Stocks, you always see like the stick. I think that's the name, like candy stick plot or something. Let me just find stick candy plot. Oh, sorry. I don't think it's candy. That's the name to it. Because the name of the plots comes from Japanese food, if I'm not wrong. But I can't really recall the name of it. But histogram is where you can see the pattern and also the values that is a force behind it. Okay, and then they shows on join plot, so you can see the histogram and with the scatter thing, it specified that it wants it to be a scatter plot plus histogram. Okay, and then what else do we have? Join plot on scatter with alpha 0.3. Alpha 0.3 is on the weightage, if I'm not wrong. Let's see. Okay, DX is DFRM. Yeah, I think it is on that. Let me see the description of it. You got the set of transparency for the dots, so the concentration. Yeah, you can see the frequency of it. Okay, so the higher frequency that the data falls, like in this end, you can see here the color is thicker, meaning that more data actually falls on that dots, and less data falls on the lighter color dots. Okay, shapes through. Okay, so this is something like an area plot, but not really. Okay, it's called KDE plot. Just give you more context of that. KDE plot. Yeah, it's very similar to area plot. Let's see, a method of visualization, the distribution of observation, analogous to probability density curve. Okay, I think the idea is the idea of this plot is very similar to area plots. Yeah, so you can see by having this color and the concentrations, can see more data is actually happening on this middle, around 20 on MEDV and also 6 of RM, right? Okay, so this is for you to understand more about your data, because when you actually plot it out, you can see like what is the correlations and where is my data happening more for a specific columns. So for this pair plot, you can see more like on the scatter plots, bar plots, histogram. They don't have a bar chart. Okay, so just to ensure that you guys don't have confusion between histogram and bar chart. Bar chart is split. Okay, histogram is stick together, and normally histogram is more suitable when you are having a continuous data that stick together. Okay, and bar chart is more suitable when you have category and numerical. For example, if you assume this is like students that are studying diploma in APU and students that are studying PhD in APU, right? And these are the numbers of the students. So that is some of the context of how and which chart you should choose on the data that you wanted to look into. And I think online they have a lot of source on like teaching you what is the plots that you should use on a specific data, like numerical to numerical, what you should do, numerical categorize, and what plot we should do, like pie chart maybe. Maybe you wanted to do donut chart, right? So yeah, these are more context to that. And of course, in this workshop itself, it teach you on how do you see the correlations, okay? And what is data preparation, okay? How does the data cleaning works, okay? And what is the most common things when you need to work with data that is not clean before, right? So apparently you need to find for null values, you need to identify is there any outliers, do you need to remove it, and on the null values, do you want to fill it or do you want to remove the whole null values? So yeah, this workshop actually give you a context of how you can do that. But in a more deeper sense on data manipulation, you might want to, like for example, your data is like the row and the column is misplaced, right? Maybe your column is actually on your rows, so you actually need to pivot it or you need to change it accordingly. So there are more things about data manipulation, but I think it covers quite a lot of basics that you will need to know. So yep, that's eventually covers everything that I have today, and hope you guys learned something out of it. And yeah, thank you for attending. And of course, if you have any questions, you can ask in the chat. I can answer it accordingly. And yep. I think I will leave the call until 10:20 if there are no any questions. But anyhow, thank you for attending, and I guess I have 2 more events for MLSA coming up, which I posted everything in Luma. Let's see. Yeah, there are 2 more. So the gentle introduction to AI is more like a Gen AI services on Azure, and the second one is how do you build your JavaScript portfolio using React, and we are using GitHub code space, meaning that we don't even need to open our VS Code. Yeah, we can code online. Okay. Yeah. So yeah, that's basically it. And yeah, if you have any questions, you can ask in the chat or you can unmute yourself. And yeah, thank you for attending. Hope you learned something. Yeah. Okay. Guess there are no questions. Okay. Since there are no questions, I think I can end the call earlier as well. And yeah, thanks for staying until so late because it's a bit overtime. Yeah.